the room and talk about which part you don't understand.
Uh, Personally, I think they did not go like deep enough into the method, which I felt yeah, which is something I wish that they had done. Like I would appreciate a algorithm. Um, yeah.
Uh-huh.
What
Agree.
are what are your opinions?
Um, I think the GRPO, I haven't fully understand what it is yet. Probably because I don't know enough about the whole reinforcement learning with human feedback, the PPOs and the GTPO, something like that. I don't know those yet. So it's hard for me to immediately jump on this one. Um, and then they also mentioned some other things. I think some other things are in their previous papers about why they can only activate a subset of their parameters and why they can be so fast and so cheap. I think that is not on this paper, so I don't understand it yet. I think when we come here, we want to know why this thing is so powerful, but R1 is built on already very powerful things like V2, V3. And so today we're just gonna focus on R1. Despite that V2 and V3 should be future sessions. Yeah.
I was actually going through the other paper because, like Sheeta said, I couldn't find a lot of math or algorithmic details here. So I was going through the GRPO paper, like the one which they use for DeepSeek math model. That had a lot of details on reinforcement learning part.
Yeah.
But then yeah, I think I agree with everyone. But I've been playing around with the model a lot, obviously. But I'm really shocked at how the reasoning is like crazy. I haven't seen any of the models do that. It's literally walking through like a person would think. And that aha moment that they mentioned in the paper, I saw that a couple of times, just like taking a step back, like, wait, the user also said this, so let me change my response midway through like quote unquote thinking. And then, tailor the response to that. So that's like freaking amazing to me.
Yeah, I agree. I think this is the first product that we see thinking as part of the outcome, because all the other products, they say they have all these COT, GOT, all these different thinking, but we never see it. So this time is the first time we see them, and sometimes I even think the thinking itself is part of the product because it's nice to see how it thinks.
I was reading today about this news that they apparently use distillation and there's like theft of OpenAI data and all of that stuff. So that was interesting.
Dude, I mean, I feel like at this point, none of the LLM models or anyone who's creating them should ever claim like theft or anything because they have all used data from all over the world, from
Yeah, that's true.
everyone over
That's
the
literally what I was
internet.
gonna say.
So
Aren't they
it's
getting
like,
sued by the New York Times for like literally
Yeah.
copy pasting articles?
Mm-hmm.
Yeah, agree.
Nikki, what do you think?
I came for the discussion. I didn't have time to go very much deep in it. But I came more to listen to other people's thoughts.
Okay.
Which was the
So
paper, Shefali, that you were saying that has more details in it? I would
It's DeepSeek math.
DeepSeek math. Okay.
It's also on their GitHub repo. Wait, where is
Mhm.
it? Oops. Ah, where did I go? Oh, this one, DeepSeek Math, pushing the limit of mathematical reasoning. So this paper is the one that introduces the GRPO, the group relative policy optimization. Wait, where is it? Oh, here. From PPO to GRPO.
Yeah, this is the part that I didn't get either, the GRPO. I was lost.
Yes, we can go over this section from this paper, or if Shefali understands this part, you can also um help here. But yeah, like that is something that I also needed a little bit more detail on.
Well, I mean, I went through some videos to understand PPO and RL a while back. I Oh, okay, Niharika is still at work. Um, so this
Hey.
is, I think, PPO's objective function. Jason, do you want to scroll down? They have a comparison model, PPO versus GRPO. Yeah.
Oh, yeah, this one.
Okay, so like Q is a question. Um, you can think about policy model is the one that you're trying to train. So it's like the LLM. So the question goes through, or question is like a series of tasks basically, which goes through the model and
Or
it gives an output.
right?
And then
Or
you put the output through, in PPO, you put it through a reference model, a reward model, and a value model. So value model is again another really big model that has a lot of trainable parameters. So the overall optimize, like in RL, it works is that you put it through the reference and reward model, it gives you a divergence between those two distribution, and then you kind of calculate something called advantage, which is how, in which direction do you want to kind of take a step? Like, should you add or remove the delta in your weights? So that A, the advantage which is on right hand side, it feeds back into your policy model and then you keep repeating it. And that's the training part of it. And from what I understand, the GRPO optimizes on PPO because it doesn't have the value model. Instead of using one question, one output, and then putting it through the value model to get the correct response, so to speak, they adjust the temperature setting of their policy model to get a multiple outputs, which is O1 to OJ, which you see. Can I annotate here? I can't. Okay.
I think so.
Can I?
Yeah.
I don't see the option. Okay, but this near GRPO, the O1 to OG you see, that's the output from one question that comes out by adjusting the temperature setting. And then they actually just take the mean and divide by standard deviation. And they also do a little bit of adjustment to find the average reward function. And they use that. This R1 to RG is the reward for each output. And then they use that to calculate A1 to AG, which is that advantage that you need to feedback into the policy. So they calculate that, they take the average advantage, and then they feed that back to the policy, and then they train like that. So then you don't really need like another value model to give you the baseline parameters. You can just use different outputs from the same question and take the average or advantage of that to keep training iteratively. Like that's the basic of how I understand it. If you go down, they have like some of the, yeah. So like, okay, so this one, for example, tells you, yeah, I could not figure out how many outputs do you have, the G number, where they came up with that, or is that like a tunable parameter and they keep, I don't know exactly what they do. But this is a pretty standard from, I can understand, RL function from a different paper. But what they have changed basically is instead of doing it for each output, you're doing it for a group. And then if you scroll down even more, Jason, you will see that yeah, this is algorithm, you could go through it. But like if you scroll down more, they give you how they calculate the average basically. This one, yeah. So this AI at each T is calculated as the reward, which is they take as from the reference minus the mean divided by standard deviation. So very basic standardization. But that's what I understand broadly from the diagram and the paper and other RL YouTube videos. I'm also not an expert in reinforcement learning by any. Yeah.
My understanding of this, so my understanding of Q is just prompt, okay? So
A
for example,
question, yeah.
Yes.
solve this legal question, and then policy is the unreinforcement learned, or did not the one that did not reinforcement LLM that for example generates some legal code, Python code, and
So
then reference model basically tells the reinforcement learning not to deviate from the original model too much. Reward model gives a score of how good your Python code is. But I don't understand enough how the value model is and how in GRPO that it is just throw away because there is groups. Like where do they come from? Mm-hmm.
So what I understand is, in general, how this is value is going to be the value of reward for each of the possible actions that you can take, um, or like the future value.
Future value. Yeah.
Yeah, future value of each of the actions that you can
Reward.
take.
Mm-hmm.
And that you can that kind of gives you the advantage of this specific action or O that you're planning to take. In GRPO, from what I understood from Shefali, I think instead of getting a value from the value model, they are just averaging out the advantage out of a lot of these different ones and taking that as the baseline. Or is that what they're doing? They should be maximizing or minimizing some objective, right? Are they trying to minimize the difference between the average and the action
They
that,
definitely
or one
want
that they choose?
they definitely want to maximize the reward,
Yeah,
right?
just the reward is what they would maximize because it's purely reinforcement
Right.
based.
They
Yeah.
would maximize the reward, but for maximizing anything, you need something to compare against, right? Like,
Yeah.
so are they comparing against the average of advantage or what?
Scroll down a little bit. There's an objective function. I think it just shows.
Here.
Yeah. So they maximize this.
Right. So they are trying to do,
So wait,
um,
what is this?
It's like for each group, 1 by G, they sum over for each output for each group, basically, the minimum of the output of the current policy divided by the output of the old policy. Old is like one before because it's iterative, right?
Uh-huh.
And then the minimum value that the four ones that you see over here, that's from a different paper. I haven't read that. But there's another method to find again we're trying to find out like how much I don't know how to like how much steps are we taking in one direction. I don't know why they have this E that you see over here. That's also a tunable hyperparameter from my understanding. And the logic of that is from the very different 2017 paper. um but yeah.
okay.
Okay,
Um,
here. I don't know if you can see. Um, not sure if this is clear. So this entire thing is pi I. It's indicating how much the new policy diverged from the old one. So this is the KL part, right? They don't want you to be
no, so there's a separate KL part in the end.
which one? Oh, this one is the
Yeah,
KL part.
this is the KL parameter.
I see. Then what does this pi do? Okay.
It has a similar objective though, you're right.
No,
Yeah.
it's not pi, it's the likelihood of new policy divided by old policy, what we were seeing in that paper. Remember, it
Uh-huh.
was pi of new divided by pi of old for particular question and output. I think it's
Uh,
that likelihood for each I.
So for every output that you can get, you want to minimize the likelihood of that being generated by the old policy versus the new policy. Like those two should be similar.
Yeah.
So essentially, that's just saying that the two policies should be similar.
That
well,
doesn't make sense though.
I
Yeah,
want
because how would it train? Like how would it move
uh,
forward if
this one is the penalty.
correct? It's the last term.
Yeah.
But you also multiply it by advantage, right? So that's where the training part happens, I think. Like you're
Okay, so
basically
it's
saying
high
you
AI
can move.
is like a
Yeah.
weighted average.
Yeah, of all the outputs from O1 to G.
So what, I don't understand the clipping mechanism that they say that could destabilize training. What could the training be destabilized by?
So they're
That is
trying to
if the divergence is a lot, if there is basically it's used to prevent large updates in the policy when we are training the model. So if there's like too much of an update, then it can deviate, too much of a deviation from the old policy, that can cause the performance to go bad.
Okay.
I think the
And how do we choose the E or epsilon that controls the clipping to
it's
prevent
a
overlay?
parameter.
The hyperparameter, right?
Yeah, it's a hyperparameter.
Yeah, I was asking like if you understand from this paper, how do we choose what E should be so that we don't allow these drastic changes in the policy of the model?
I
Mm,
think the
I just know in
programmer did
general it's a very small constant, like it's 0.1, 0.2 kind of a thing.
mm. Yeah,
Mm.
awesome.
But they don't mention it, yeah, like which values they
Yeah,
use
that's
exactly.
not. No. Mm-mm. No, this is DeepSeek. I want DeepSeek math. Mm-mm.
Let's see.
Okay. Yeah, I don't understand this enough yet.
I think this is built on like a lot of deep RL work, which we'll probably have to go back to understand.
Yeah. Mm-hmm.
Exactly.
Okay, so let's come back to R1. The first question is, how is R10 trained? And what's nice about R10? What is its limitation? And then how is GRPO different from previous PPO? I guess we already touched on that, which we don't understand it enough.
I guess R10 is predominantly just using reinforcement learning. They use questions and then which are like prompts and then answers for them, and then keep iteratively improving the model using the GRPO method. They have a section of prompt that they have tried to also add in terms of format, which is think, in which they are trying to make the model explicitly put the reasoning process and logic, which is, I think, one of the like interesting things through which like they have kind of like achieved this thinking sort of process, which is unique to like the current LLM landscape.
Yeah.
What's not good is I think it's not able to, readability is low.
Mm-hmm.
It doesn't, like, it is able to give the response. So I think they started from like a math sort of a perspective, so they're not that big on readability. So for that, I think then they trained R1 from R10.
They also mentioned language mixing Do you know what they meant by language mixing?
Oh, I know what it means. It means when the Chinese are speaking and they have lived in the States for a long time, they start speaking a mixture of different languages.
Oh, okay.
Yeah,
Yeah.
so the model is not able to mix the two that well. I think that's what they said for R10, but then it improved on R1, and
Uh-huh.
it's mostly only trained on Chinese and English, I think.
I think in R1 because I think they have a reward that is they have a format reward that is I don't think it's here, but I think somewhere they say that, oh, they're gonna reward if they only think in English or if they only think in Chinese.
Reward the model, like
Re-
as far as the reinforcement learning, say like, okay, if you only speak or respond in one like context, that's
uh-huh.
behavior we want to.
Yeah,
I thought
But
they were
if the
trying to
user
promote.
is using like multiple languages, how does it know which one? Sorry, go ahead, Vito. I think that
Yeah,
was you.
I think that was one of the challenges that it's not able to do language mixing. So I think they were trying to promote language mixing actually. That's what I understood from this.
I think the cold start, wait, is it the cold start or is it I think in R10 they have the mixing and in R1 they fix that. But in R10 they're trying to say that, oh, if you have mixing, it's actually good for the thinking or for the reinforcement learning it's good for the model to become really smart.
Oh, interesting.
I don't know.
Check 2.32. I think they talked about introducing another metric, like number of
Yeah, I
tokens in
remember.
language or something. Yeah, here, language consistency reward.
Wait, where?
Yeah,
Um,
I see it. I see it. To mitigate the issue of language mixing, we introduce language consistency reward. Proportion of target language words in COT in the middle.
Oh, here to mitigate the issue. Oh, okay.
it's just in the output then, not in, but I think Michelle was saying about what if the user is mixing in
says
multiple languages.
It says that if I do that, it's gonna not get so smart. But it's
It's
gonna
the
be more.
readability.
So it's saying that the smartest robots actually think in very many different language.
It's
I
not
can
limited by
see.
one language. It's just like let the thoughts come.
Yeah.
Can it, like, based on context, if it doesn't know the language or something, fill the context in like kind of with the surrounding words that are in the language that it knows? Like, I guess, could it fill that gap in and then go forward predicting like
I mean, a lot of us are multilingual. We know the feeling when something can be described better in English and something can be described better in another language, right? So I intuitively I think that is why language missing makes it smart.
That's such an interesting point.
and more
Oh,
accessible? Like,
oh,
it seems like they really want to have it be more user friendly and more like sturdy than experimental. So while they are experimenting, it's like they're kind of doing it in bits and pieces, which allows them to make these assessments and make a decision like, hey, okay, we're gonna have language mixing, whereas like we wouldn't before because it seems like users like it, and now we're gonna go forward and do that. But they wouldn't be able to do that if they had to have big updates on the model, which is why they have those clipping things and other stuff to make very like small adjustments. I'm not sure. I barely read the paper, so but it's pretty interesting. I mean, everyone in my office is talking about it. the idea that I got was that they basically kind of distributed things, made it a lot more supervised, but not supervised that they had to go in and redo the model like you would for supervised learning. But they were able to see each stage of it, and then that helped them make changes really quickly, basically, based on user feedback. But as far as the math,
Reinforcement learning part has no user feedback.
what if the part or this part didn't? Like the
Oh.
training part?
Bro, the zero model has no human feedback or have
Oh.
no supervised training. It's the R1 that added some of the supervised fine tuning, right?
But
Yeah.
they were only reasoning tasks. So they had like the answer to the coding problem or the answer to the math problem as a reward. So they didn't need, but that's why they were facing all those issues because it was only trained on like those
Exactly.
reasoning and logical tasks.
Mm.
I was looking at a video where they said that the reward was tied to, yeah, I think you're right. There has to be a certain answer for like a math problem, but it was almost like the response was like if it asks for 2 plus 2 or something like that, the first answer just says something like echo 42, which is a code, but it's not like related to what this thing is answering. So, and then it would give an English sentence, and then it would constantly get negative reward. And after a while, it would start converging to actually writing the actual code and getting the response and passing the test cases. And once it was passing the test cases, that is when it would get a very high reward. So that's how it was implementing the RL. So yeah, it was they had like test cases that it had to pass through.
You guys want to go through the algorithm in the previous DeepSeek math one? There was like some algorithm here as well, I think. This the one below.
This is the GRPO.
Iterative group respective policy optimization. Yeah, this one.
Yeah, and we just talked about this one. Sort of.
So basically, we have a policy model that can say what would be the,
Next token.
yeah, or what would be the response for this input. We do the iteration. We have a reference model. Reference model is some model that's good, let's say, something like that. Are we assuming that reference model is good, or are we assuming reference model is at the same level as the current model?
Reference model is a frozen current model.
Frozen, okay, got it. So it's
Based
not updating. Right.
Reward model is the one that has a
It's
score.
updated.
So for example, here it will be, can you solve this leak code question? Can you pass all the leak code test case? Or can you solve that math question?
Right, okay. So we go from step 1 to M. I don't know what M is here. Sample a batch DB from D. Task prompts. So D is the prompts that we have. Update the old policy model. Sample G output. So we get G outputs out of that. For each question, compute the rewards for each of the sampled outputs by running our which is the reward model. So we can get the rewards for all of them. Compute the advantage for the tth token of OI. So for one of the answers,
Group relative advantage estimation.
Is
That is the weighted
advantage,
average, right?
is advantage like the differences for with the reward, like how much reward it got versus negative reward, basically?
I
So you would
think
like,
I think advantage is the possibility of future reward, like
okay,
cumulative
over other
all,
models, kind of like, or
all
something?
the, so for
No.
example, you these are all the actions that you can take. You can, at this point, you are playing chess, let's say, and you can take action A, action B, action C, right? When you take action C, what is all the future reward that you can possibly get, discounted and cumulated back to the current point, something like that, I think.
But it's not comparing other possible
This
paths.
this is a group
Okay,
relative
yes.
advantage estimation. Generally, I think advantage doesn't do that.
Thank you.
Yeah, so we can then compute the advantage of the tth token of O1. So O1 is one of the responses. For the tth token, we are going to compute the advantage. For GRPO iteration 1 to mu, what is mu? Update the policy model by maximizing the objective. Update the reward model through continuous training using the replay mechanism. Okay. I think there is a need to.
It.
Okay, yeah, there is that algorithm still needs a lot of background reading. So yeah, Jukson, go back to the main paper. Sorry for diverging again.
Yeah, it's okay. Okay, so R10 only has this GRPO, and basically the reinforcement learning just reward two things. The first is, can you solve this legal question? And the second one is, did the model stick to the format that has a think and then has an answer? And then that's it. Training template. What does training template mean? Oh, training template is this one that has think and answer. So then when they train this reinforcement model, they see the aha moment, and they see that the more they train, the more accuracy it gets, and the longer the reasoning gets. The average length of the response just gets long and long and long because the model start thinking too much. And then they start to see the aha moment. And the problem is poor readability and the mixing languages. So that is okay. So DIP10 R10 is done. Any other questions except for this algorithm?
I think if there's anyone, like all CS folks and software engineering folks, do you know why the hardware optimization of this was such a big deal? Like, what did they do such that they didn't have to use those expensive NVIDIA GPUs or something? I don't have a
What's
lot
it,
of
the late AUX like compression,
I think so, yeah. I
something,
don't mean the distillation. I think I
in
also
the
read like,
paper.
yeah.
The first one is fixture of experts, meaning that you train several hundred of billion parameters, but you only activate 37 of it. Because there's like a router that you only use a certain experts and you don't use all of them. So you use less GPUs. I don't understand it enough. That's another paper that they published before. And then there's this multi-head latent attention that compresses the KQV into a lower dimension latent space. This is also a previous paper. And then this FP8 quantization, I don't understand it at all.
Quantization is essentially like generally all your data is going to be stored in a 32-bit format, right?
Uh-huh.
So, for example, if your computer is a 64-bit computer, what that
Mhm.
means is that every letter or every character is stored in the memory as a 32-bit number or a 64-bit number. Um,
Mhm.
they are reducing that to like an 8-bit floating point.
Oh, okay. Okay, that's very hardcore. I don't think about that on the top of my mind.
Is that 32 bits for every one of those like billion parameters? And because I'm imagining if they reduce it to 8 bits for all of those, that is a huge,
Yeah.
significant like increase or decrease in computing power.
Yes.
Especially if they're only using 37.
I think quantization was done in previously as well in LLMs, though this is not something that only they have done. As far as I remember, there was somebody else who did this.
Okay, that makes sense. And they also said that enhancement in R1, they use some adaptive bit width scaling or loss-aware quantization. I guess it's just fancy way of quantizing.
Clueless, clueless.
It's
I also found
pretty
this
fun.
in page 11 to 12. They talk about the low-level optimizations that they implemented to
Which part?
yeah, it's page 11, I think. A little bit below. Yeah, a little bit more further below. It's 3.22. Oh, I put another
Link in the
uh,
Zoom chat.
link to the it's a different paper. It's in V3 that they're talking more about the different how they basically trained it so cheap, and that they implemented different low-level code optimizations to make memory usage as efficient as possible. And they use this technique called cross-node all-to-all communication. Yes, over there. I think that's where there's more information on this. And then it was also training optimization to focus only on the important parameters. I think, as Chusin said, only 5%, I think, of the model parameters were trained per token. And
Oh, sorry.
mhm.
I was just gonna ask, how do you decide what parameters to use, or is it is it dynamic?
This one, the mixture of experts. So you have some experts that always activate it, and then some experts have a router, right? The
Mhm.
router only let you go through some of them.
What is
So
an
the rest,
expert?
It's called auxiliary loss-free load balancing, this method. And they ensure that only the most relevant experts of the model, as Chusin says, were activated and updated. I don't know how these experts get chosen, but I think if we look deeper into this technique, we could find more information.
What's an expert? Is it like a layer? Is it at each layer
Uh,
transformer is an expert?
Experts or relevant parts. That's how I
Of the model?
neural network,
yes. Yeah.
Oh.
and there is a router, And then the green ones are shared experts, meaning that they will always be activated. And the blue boxes are the routed experts, meaning that they only get routed to some of them. And the rest
The
of them they
layers, right? Because if there's activation involved, then it has to be some kind of neural layer
Yeah,
in
it's a
between.
transformer block, I think.
Okay.
yeah, this is the entire thing is a transformer block. Uh-huh.
Oh,
How
I
does
thought
which one
one
is
expert
shared?
is a transformer block.
But that's the feed-forward network expanded. So I think that
Oh, I see.
Ah.
Yeah, they're zooming in, I think.
Okay.
Yeah, that's the yeah.
Just call it layers. Why so many new terms?
yeah,
Now
exactly. It's so confusing.
Now I'm thinking, who's an expert sitting inside a transformer?
It might be a language mixing term.
Oh, oh. But this is not new to V3. This is introduced in V2. So we need to read the V2 paper as well.
They have done too many optimizations, man. Not even at like firstly the algorithm itself is so different. And
Yes.
then even at such a lower level, there are so many changes. That is
Mm.
Did you say
But it's
there were
very cool
200
that,
contributors? Sorry, go ahead.
oh yeah, I was just gonna say that it's really cool that they experimented with these techniques and showed how they could completely change the game, like improve accuracy with RLHF. So not only use it to remove bias or hate speech and so forth. So it's very nice.
Mhm.
yeah.
Now we have like Alibaba or something that came out, right? It's all over LinkedIn.
It's
Quen.
all
Really?
open source.
Day off on
That's
Chinese New Year.
Yeah.
Oh my God.
Yeah, this is just like scratching the surface of the amount of research that they have. So I mean it makes sense how they got such good results because they have so much, so many optimizations piled up at this point.
Building layers.
yeah, I guess the really surprising thing is at that level of optimization, you would expect some deterioration in like quality, model quality, or like the magnitudes of which they were able to make it more efficient. You would expect some level of like a little bit, but it seems like it's performing at the also the same level as far as from what I can see and what I've heard. So
Yeah.
that's kind of the most surprising part of it because I feel like that kind of pushes companies or other AI engineers to think more outside the box. Like,
Mm-hmm.
yeah.
For sure. I think we should read some of their other papers.
Oh my God. We need to read R1, V3, V2, and math.
Math.
Definitely I'm interested in
Let's
the
start with
math
math.
one. Yeah.
Otherwise, every time we'll be like, we need to read math first.
We should do a 2017 paper on PPO and TRPO then before we do the math. So we
Oh
understand
my God.
TRPO is good.
Yes. And yeah, oh, this one has a table of all the reinforcement learning. Here. Yes,
Which, by the way, was released by one of the researchers at the co-founder of OpenAI and now a researcher at Anthropic.
at PPO, DPO, KTO, APO, and GRPO. Oh my God.
We actually
Reinforcement
haven't done a
learning
lot
is
of Sorry, go ahead.
reinforcement learning is a very deep topic. So it really needs like a lot more because I feel like we've done some like language level stuff, time series, recommender systems. We haven't really done too much, as Shefali said in the
I mean,
series.
the recommender system has some overlap with reinforcement learning. The reinforcement learning is a giant topic too. I actually look over some study materials of reinforcement learning, but all of them are very outdated.
Yes,
Yeah.
there is one book that I was taught during my master's in a course, which is like a fundamental book. And then now there are like so many new things like.
Okay, we're done with this one. We're R1, how to train it. So the different thing compared to zero is just some some supervised fine tuning at the beginning as a cold start. I guess it's like at the beginning of a network, you want to take a very large learning rate, or you want to take very large gradient towards the direction you want. And then once you are in the right direction, you can do all the small things. You take small baby steps towards reasoning. That's what I understand. Which paper is the? I've lost the paper.
On a side note, if someone gets like an entire picture of the architecture somewhere, it's not in the paper and I couldn't find it online. Or any kind of flow diagram, just share it on the WhatsApp group, please.
J. Oliver wrote one. It's him again.
And oh my God, our savior.
Oh, it's him again. So he just
I love this
published
one.
this 2 days ago. And basically, yeah, this is what it is. This is the R1. Uh-huh. It starts from V3.
Can you
Use,
send the link to the chat by any chance?
it's him again. So
Thank
basically,
you.
understanding is you start with V3, and then the cold start uses some supervised fine tuning, and these data are really nice data. For example, how to do a math question or how to solve a leak code hard. And some of them are even from R10, but because R10 is low readability, right? So they make human to revise some of the R10 answers to be just English or just Chinese. That's what I understand. And then once they get to this SFT checkpoint, they start doing what they were doing, the GPRO in R10, which is the fine tuning. And then they get R1, which is what we have now.
Sheetal, is this a book that you sent from your master's? Okay.
Yeah, so this is like a very fundamental resource on RL. It's a book by Sutton, I think Richard Sutton something.
Be old already.
Yeah, he's dead probably.
I mean yeah. I
But
mean
I think
new algorithms are new, meaning that they're outdated already, probably.
no, but I still think fundamental concepts
Uh-huh.
are like it's sensible to read them, but there is a lot of things that have been done on top of that
So yeah.
book. So
Also for
there'll be need to understand
yeah.
the new things as well, but you will not understand the new things properly without um, looking at
Yeah,
the old.
without those all the Q learning things.
Exactly. Exactly.
Yeah, I agree. Yeah, those we need to learn too. Many things.
Yeah, actor critic and all that.
Yeah, the bandits. I think all we know the bandits, and then the Q learning things, and then and then last time read a paper, the exploitation and exploration and exploitation.
Yes, we did that, I remember.
Yeah, uh-huh.
Yes.
And then now we're here. We're at GRPO.
My God, dude, how fast is this thing moving?
Uh-huh. Okay. So cold start, I guess we now know a little bit about it. And then second part is reasoning oriented reinforcement learning. My understanding is because R10 has so many thoughts that it thinks so much. So R1 just use those thoughts, long chain of thoughts. They thinks for thousands of tokens, right? So just use those as the reinforcement learning.
I have a question for
Uh,
everyone, not just you, Jason. But like, how do you do chain of thought training? Not just for DeepSeek, but even in general.
I I thought that they basically provided a chain of thought, or they asked the LLM to produce the chain of thought, and then they used that those examples to train.
So you give a
Um,
prompt initially to get a set of outputs, which are chain of thoughts for different tasks, and then you feed that into the model and then ask, and that is the input, the steps, and then you give the output.
Yeah, and I think initially to get that sort of an output, I think they asked the model specifically explain your chain of thought, something like that. Because I remember reading that was something that was part of some other paper. That's what I remember, but yeah.
but
yeah,
chain of
normally
thought
chain of thought is
sorry, you go ahead.
yeah, so normally chain of thought you do it after an LLM has been trained with a system prompt. And to achieve it, you can also give it examples of taking a problem and breaking it into smaller steps, because give me your chain of thoughts, I think it can be quite vague. But I don't know how, what's the next step? Yeah,
Yeah,
exactly.
they
So
added phrases like this, let's solve this step by step, so that like the LLM has to kind of give some reasoning for what it's doing rather than just give an answer. Like a lot of times when you give it a math problem, it would give the wrong answer. But if you give it a prompt like that, then it would give step by step how it came to that answer.
yeah, and then giving the example also helps of how it was broken down. But so you think, Shiral, then the outputs, the generated outputs, get used to train the model with RLHF?
RLHF is a completely different thing, no?
Yeah. I was just asking if like do they so a model needs to be trained, like to have a base model basically, then to use a system prompt that makes it use a chain of thought, break the problem down in smaller parts. So how do they then integrate the generated, I think you mentioned that they use the generated output using chain of thought to retrain the model? Okay, maybe I missed what
No,
was
so
just mentioned.
I'm just saying what chain of thought is. How they used it here is, I'm not sure actually. Probably they just used it for the initial training.
Okay. Long chain of thought examples. So I'm assuming that chain of thought is a prompting strategy that prompt R10 to give some very long reasoning examples so that you don't need humans to write these examples. You R1 can do all of them. And then you ask some humans to change the language back to only English or only Chinese. Okay, and then these examples are used to fine tune V3.
Yeah, so exactly the what I was saying, there is a base model that needs to be prompted with chain of thought, like with a chain of thought reasoning. And then from what I see there, they use supervised
Tuning.
fine-tuning
Mhm.
to retrain, I guess, certain layers or all of the layers with that data.
I see 2.33 section here. So basically they do GRPO with that cold start data, and then they get, once the algorithm converges, they basically have the output which can feed into the model again.
Yeah.
And then you fine tune on that output basically, which has COT
Yeah.
examples from the previous GRPO cycle. And then it gives you the final model.
Yeah.
Okay.
Okay.
Wait,
That
I
makes
thought you first do fine tune and then you do GRPO.
Sorry.
I thought I
Um,
fine tune first and then you do GRPO.
from that diagram, I think they first need to generate the data and then use that data to retrain it with reinforcement learning.
Oh, I see. I know what Shito means. Shito means that before this, there is the R1. There is the 0. The 0 is also from this thing, but with GRPO only, right? So my understanding is to get R10, you just do GRPO on the
Yes.
base. And then using this smart but mixing language 0 to get some long trick-o-thon examples. For example, solving legal questions. And then use them to cold start V3 again. Now, after cold start with this SFT checkpoint, okay, now you do GRPO all over again.
Correct. Yeah, I agree with that. Basically do GRPO, then do SFT on top of it. Then use the checkpoint that you got from there to do GRPO and then create the DeepSeek. Yeah.
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 They did mention secondary round of reinforcement. I think you're right.
But I was surprised that they didn't directly, for example, go from 0 to R1. Directly fine tune this. Instead, they use that to generate some prompt to cold start V3 all over again, and then do another GRPO.
I think it's like faster, right? Like SFT, I think is faster overall than using reinforcement learning, right? Because that would be my assumption that like supervised learning should be faster, so it'll get them some way.
I think it's also about data, right? They generated the reasoning data from that first model after it converged. So they didn't have that data. And then they did a second, they did reinforcement again.
Yeah, actually, if we scroll a little bit further down, they show, not in this, in the other link, the newsletter.language models.
One.
Which you said before that it was, oh, this guy again.
Jay Alamar, the blog.
Wait, let me. Yeah, they show the diagram. Yeah,
Yeah.
Can you zoom in?
that you just draw.
It's, I think, her question, like Shefali's question is below this diagram, below the second diagram. But wait, if we have this data, then why are we relying on the RL process? It's because of the scale of the data.
Oh, because SFT is fast, but RL is long, slow, right? Or not?
No, I think let's just go up from there. Let's start reading to get to this point. Then we'll understand.
You want to read Jay Alamer's newsletter or you want to read the paper?
The same thing, J. Almer. Stay with J. Almer. He will explain everything.
Just
Okay.
zoom in a little bit, please.
Where?
Just in your web page, just zoom in by a little bit. Oh wait, I
Mhm.
clicked on my zoom as well. Okay. Thank you.
Bye-bye. I think I'll bounce as well, but thanks for the J. Almer paper. I will read this and
Yeah, I think I'm gonna read this blog post.
Yeah, same.
yes.
Okay, let's wrap up. Lastly, does anyone want to talk about, does everyone know what distillation is?
Yeah,
Using a big model to create a
Okay.
small
a
model.
small one.
Yeah,
Speaking
this
of the
is
big model.
okay. So that's it. We can wrap up. And then they do some non-reasoning data as well, I guess, such as writing, factual, QA, blah blah blah. Okay. And then reinforcement learning is the same thing with zero,
Mm.
I guess. But because they co-started it, so now now they do reinforcement learning. It's stable, it's nice readability, aligned with the humans.
Mm.
Yeah. Okay. Final thoughts?
Good paper, good discussion, and I feel like they actually did something very different, like out of the box. So that's quite cool.
Yeah.
I agree. I think I'm just still shocked at all the optimization parts. All that low level coding goes straight over my
I
head.
feel like there's like a paper before a paper before a paper.
Yeah.
Like a trail of papers.
I know. And then, yeah, and not just DeepSeek, right? Like there's 10 papers they base their work on. So I just feel like Sheetal's book might be helpful. I might actually